DNA template, and then this is the growing chain. So when you're adding another nucleotide to it, your enzyme will have to hold both this growing chain and also your nucleotide. Hello? Okay? So therefore, this DNA polymerase enzyme can only add the phosphate of the new nucleotide to the carbon number 1 to 3 to the OH of carbon number 3 of this terminal nucleotide. Okay? So because of specific enzyme, the way the enzyme holds these two substrates, you can only add new nucleotide here to here. That means you only add phosphate to here. So because of that, the new chain will always go from 5 prime, because this is phosphate. Okay, this is sugar. So this is carbon number 1, 2, 3, 4. The fifth one is here. So this is carbon number 5, 5 prime. Okay, and this is the last one, is 3 prime. So it goes to 5 prime. Okay. Why suddenly I got so many red pen? Tell me. Why so many red pen? Okay, because I'm the teacher. Okay. So because of using this principle, if this is 3 prime, the new chain must be 5 prime. So it will grow in that direction. It's continuous replication, 5 prime to 3 prime, no problem. But in this case here, it's different because we will not unzip the chain and start after you unzip the whole thing. The halfway through unzipping means now I unzip until here. All these ones are still connected one. Okay? The nitrogenous base are still held together. So this is my DNA. This is helicase. DNA got helicase one. Helicase. Okay? So once I unzip until here, this one is 5 prime. So the means here is 3 prime, right? My 5 prime is there, right? So I can only add in that direction. 5 prime to 3 prime. So once this DNA helicase continue to unzip, this is called the lagging strand. This is called what? Leading strand. The leading strand continue to grow from 5 prime to 3 prime non-stop. But this one, because you start at 5 prime already, once this one unzip until here, you cannot add that way because DNA replication grow from 5 prime to 3 prime. Because if you add that way, it's from 3 prime to 5 prime, that direction. 3 prime is here. So you must grow that way. So if grow that way means you have to start from here and grow backwards. So this is 3 prime, this is 5 prime, this is 3 prime. So because of that, you end up with a lot of little fragments called Okazaki fragments.
Okazaki fragments.
Okay. And this is called the lagging strand because it's slower than the one. Lagging strand is a strand whereby it has got discontinuous replication. So this type of replication here, this is called continuous. Lagging strand produced by continuous replication, and lagging strand is produced by discontinuous replication. Why discontinuous? Because you cannot produce this new polynucleotide chain continuously. It must be fragment and fragment and fragment. So that explains.
Teacher, how do I score for this question?
Just say what I write.
Like a story or like that. Draw also can mark.
So, what is your question? What is discontinuous?
What is the marking points?
Explain or describe.
If we draw.
Describe and explain. Explain means tell me why is that discontinuous replication. Because number one, new polynucleotide strand must grow in 5 prime to 3 prime direction. Because of enzyme specificity. Twice. And number 3, when helicase unzip the DNA template halfway, the new DNA polymerase will start to add in 3 nucleotides to the template, and therefore a fragment has been produced. So as the helicase unzips, more and more fluids will produce, which are Okazaki fragments, which will be joined up by like this. So I'm sure you're pretty confident in what are the things you need to write to score based on what they're asking you. Okay, so remember, you learn out the process is one thing, and you have to look at the question. What do they want? Then answer. Don't memorize, take a whole thing. And then